Hey, hey, look who's back. It's Hot and Sexy Hot Plate and Sturry the Stir Bar. And today we are going to be making sodium silicate, or a solution of sodium silicate anyway. I have not done this before, but I have been collecting silicon dioxide for a while now, and I think it's about time. So to facilitate this reaction, we're also going to need crystal drain opener, aka 100% lye, aka sodium hydroxide. This reaction is all over the internet on YouTube. You can find people doing this everywhere. I'm hoping that I can use this for something else, and that'll be a surprise. So stay tuned to see what I'm going to do with it. In the meantime, let's just go through the motions here and hopefully make some. It shouldn't be too difficult. Okay, open wide. I'm going to jam a little bit of chemistry down your gullet. So what we're doing here is we've got sodium hydroxide, NaOH, and we've got silicon dioxide or silica gel, so SiO2. Now this is a little bit misleading, because when you think about SiO2, you know, it's a group 4, same as carbon. So when you got carbon to oxygen, what's this? That's CO2, right? So you would kind of expect silicon dioxide would be like the same, maybe, but not. It's really kind of a lattice or a crystalline structure is what you get, and you end up with silicon attached to oxygen on all 4, and then that will be attached to a silicon, which is also attached to 4 oxygens, and that'll be attached to silicon. You see where I'm going with that. And these oxygens, of course, will be attached to a silicon, and those will be attached to 4 oxygens. You see where this is going, right? So you get a lattice structure, and these are not. It's not a planar. It's not flat, eh? It's like tetrahedral. So like that, you know. And all of those are bonded together. And then what happens is, the reason why the silica gel absorbs water is it creates all these like holes. It adsorbs water. If I said absorbs, then you can just erase that from your memory. Because it adsorbs water means it just like grabs water and holds it. There's no chemical reaction going on between these two. It's just forming these little pockets that water molecules fit into, and there's got to be some sort of electronegativity business going on that holds them somewhat in place, maybe. I don't know. Ask somebody who knows about that. Anyway, this is kind of beside the point, but not really. Anyway, our reaction is this. This plus this goes to Na2 SiO3, and you get a bit of water out of that. So this is a little weird, this sodium silicate. So we've got 2 sodiums, a silicon, and 3 oxygens. Yeah, how does that work, right? So if you have a silicon and you've got 3 oxygens, it ends up like this. And now these are slightly negative, these oxygens, and we've got sodium kind of like hanging on, hanging on, stabilizing the structure. So this bad boy is what we're trying to make, and then we're going to dilute that into water to give us our solution of sodium silicate. Most of these came out of the little sheets of nori you can buy. They come in a little pack. I don't know, 12 sheets in a pack or something like that. You eat them with rice. Damn, they're delicious. I'm not even sure what the hell this is. Do not eat, OxyGuard. It seems like a powder. Let's just have a peek here. Oh, I don't think I'll be using that. Wonder what the hell that is. Okay. We'll just put that aside for now. Find out what that is later. Seems like dirt. Maybe that's what it is. Alright, now here's a tip for you. When you're collecting your silica gel, cut them open as you get them. And then you don't have to spend all this time doing this. Throw away. No throw away, keep. $18 is fine. Okay, so we have 18 grams of silica gel. Let's talk about the stoichiometry of the situation. Okay, so we've got 18 grams of silicon dioxide. What are we going to react to that? How much of this stuff are we going to react with it? I don't know. Guess? Maybe? No, not really. Our reaction is what? NaOH plus SiO2, Na2SiO3 plus H2O. Okay, now we got 2 sodiums on this side of the equation, and we got 1 on this side of the equation. So in order to balance this, boom, we're going to need 2 of these for every one of those, right? Now, we got 18 grams of this stuff. So how many grams of this? Instinct would tell you double it, right? Twice. But that's not how kind of chemistry works, unfortunately. So we really need to figure out how many molecules of this we have, and then match it with twice the number of these molecules. And we use molecular weights to figure that out. If you add up the molecular weight of sodium hydroxide, it's at, I think, around about 40 grams per mole. And then silicon dioxide is about 60 grams per mole. And if you don't believe me, get your periodic table out and do the figuring yourself, but I think that's pretty close to it. So we've got 18 grams of some stuff that's 60 grams per mole. So what we want to know is how many moles are there? And what's a mole, you might ask? That's a very good question. Mole is like a dozen. So if you have a dozen eggs, you know how many that is, right? 12. Well, if you had a mole of eggs, that would be 6.02 times 10 to the 23 eggs. A lot of eggs. You're going to need a lot of chickens for that. 18 grams divided by 60 grams per mole. Now, why did I do that? Why did I divide one by the other and not the other way around, or multiply them, or God knows what? So the point here is to figure out the number of moles, which means you want to make the units for grams go away. So what happens here, this is actually 0.3 moles. And so you have grams divided by moles on the denominator. So, you know, flip that and multiply, right? Because division is just multiplication. You get grams times moles over grams. Now you can see what's going to happen here. These are going to cancel, and you're going to be left with moles. Your units are correct. Your answer is correct. Don't forget that, kids. So we need 0.3 moles of sodium hydroxide. Oh wait, no we don't. We need twice that, right? So we need 0.6 moles of sodium hydroxide. And we're just going to use the same kind of deal. We need 0.6 moles times 40 grams per mole. You can see what's going to happen here. Those are going to cancel, right? And that is equal to 24 grams NaOH. It's as simple as that, my friends. So simple. 24 grams of sodium hydroxide for our 18 grams of silicon dioxide. And that will give us exactly enough to make the reaction chooch perfectly. Alright, let's fire this up. Throw some heat on there. Here's our 30 mils. Now this is going to get warm by itself because of the reaction with the water. But we're going to need excess heat to get the silicon dioxide to chooch. So I don't have a starter stick. I'm going to have to get something. What am I going to get here? Alright, safety first, folks. And the butt of a dental tool should do it. Yeah, I think we're good. So we'll just add it. You know what? Let's smash this up a bit first. Just knock the heat down a little bit so we don't get too crazy here. It can't hurt to just make this as small as possible to increase the surface area. So let's hammer this out. Oh, better idea. Mortar and pestle. All right, now silicone, this silica gel. Oh, actually, we might have a little bit of a problem here. I'm gonna need something to cover this with. My balls will be popping out everywhere. So embarrassing. No. Okay, still need something in there. Hang on. See, I knew I'd find a use for these bags. Okay, no go anywhere. I might have to reweigh this out afterwards. Hey, there's an idea. Before you start this experiment, kids, get all your shit ready. That doesn't look a shit bit different. Oh my gosh. Okay. Oh, and things were going so well. Okay, take 2. 24 grams of this stuff. And we're gonna do 30 mils of water. Heat and stir, my friends, heat and stir. We'll let that go for a bit, and look, lovely powder. So this is, I think this is what you want to do. Just make sure you have a nice solid surface to smash this out on. This will make it very easy for this to dissolve in that, I'm almost certain. So while I'm waiting, I'll weigh out my 18 grams here, or yes, 18 grams to make sure we have enough. We've got 18 grams of this lovely, lovely powder now. This is just going to be great for that. All right, I think we're dissolved there. So let's start adding our silicon dioxide. Now I think this is also an exothermic reaction, folks, so we're going to get some boiling action happening, I think. We'll just start slowly adding this. Hopefully things don't go too crazy on me. Odd color, wouldn't you say? It's kind of turning brownish. That's probably, oh, you know what it is? It's whatever schmoo was attached to some of those silica gel beads. Some of them were a bit yellowish. Either contaminated or who knows what. Yeah, there is definitely a bit of a scum forming from whatever was in those things. Getting tough there, buddy. Too much. Too much at one time. Okay, I'm starting over. Clean this up. We'll go for it again. Okay, we're back. It did a lovely job cleaning up my hot plate, that mess. A little bit difficult to get off, but and it was kind of sticky, eh? But not too bad. Anyway, it looks good. We're back at it. You know, I'm going to leave these mistakes in the video because nobody learns anything from when you do it right. You really don't. So this is you and me, we're both learning together. So I got my stuff weighed out here. Oh, we need about 30 mils of water here. Onto the hot plate. Get that dissolved again. This time we're going to be much more careful adding our silica gel. Much more careful. Okay, let's do it. A wee bit at a time. Yeah, so that's clearly not laboratory grade silicon dioxide. Oh, it looks foul. Okay, come on, come on. Let's see. No, 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 no. Okay, that's it. We're in. Now it's just a matter of getting it all to be dissolved. Now, if you look on other YouTube videos, you'll see that the silicon dioxide is actually, you know, this solution is nice and clear. So, like, the contaminants in here, I don't know. I don't know how that's going to affect things. But so it's just a matter of letting this boil away until there's no gritty graininess left in it. And then we'll have reacted all our reagents, and we'll be good to introduce it to the water, which is here. And then we should have a nice solution of sodium silicate. This does seem a little thin compared to what I've seen from other YouTubers. That may be because it's simply not dissolved yet, actually. There's my witch's brew there. Clearly not the most attractive solution of sodium silicate. I may need to invest in some more pure silicon dioxide, silica gel. Alright, so we'll use the old newbie here. Have a little peek at what the temperature of this stuff is. So it's about 115 C right now. I wonder if I can take some of this crud off. I'm going to do that. Just skim some of this garbage off. So something has changed, that those little particles are just now coming out of the solution. Hey, whatever that is being ejected from the solution. Maybe this will actually clear up. Alright, well, let's just test the bonding power of this stuff. I think we're pretty close. So I'm just going to put some on this washer here, and then we'll attach the Allen wrench to it. Okay, just set that on there, and we shall see if that will hold at all. Because I don't have a perfectly pure solution here, I obviously have a lot of contamination, it's hard to know when this is completely done. But this has been going for about a half an hour now. We've been skimming off the scum that forms on the bubbles. Still doing it a little bit. And it's clarified significantly. And I do feel like it's kind of done. But science isn't about feelings. So whether it really is or not is a totally different question. Assuming that it is done, we're going to put it into the water here, and then we should have a solution that we can later use. Okay, so we'll turn off the heat here, and I'm going to pour it into the water. Oh, maybe I should have a bigger hot mat, eh? And I'll try... leave as much scum behind as I can. I think I got it all in there. Scum included, for the most part. And there we have it, folks. Right then. I just let this settle for a bit, and you can see we have two distinctive layers going on here. We got some sort of precipitate or something at the bottom there, and then a clear aqueous layer on the top. Anyway, shall we descant off this business? I should have probably let it, not disturbed it so much, but let's just take this off. And leave the shmoo in the bottom. Maybe we can have kind of have a peek at that. See what that's like. Okay, I think that's as far as I'll go. Still not perfectly clear. You can see there's like a wispy kind of business going on there. We'll let that settle out too. I bet that goes clear later too. So that might take overnight though. So now what in the world is that? My bet is it's filler. That it's what they're putting in those sachets is just not pure silica gel. It's got something else in it, and that something else is there. Just a guess. But in any case, now you're probably asking yourself, why bother? And this is why. When you make concrete, it's not all rock hard, even though it appears to be. There is a bunch of calcium hydroxide in there that is quite soft, and if you walk on it or use it a bunch, it tends to powder off, and you'll get a powdery surface on the top of your concrete. The way you avoid that is you seal it, and you can buy commercial sealers, concrete sealers for fours or whatever. It's just a layer that, you know, protects the top layer of your concrete. The other way of doing it is using a densifier. And densifiers are this: sodium silicate. On more predominantly now it's lithium silicates. You can also have potassium silicates. And what they do is they actually chemically react with the calcium hydroxide, that powdery layer, and form calcium silicate, which is super damn hard and is very amenable to polishing. So once you've hardened the surface with sodium silicate, you can use your buffer and make a really nice shiny surface. That's the theory. I have not actually densified any concrete, and I've not actually polished anything that has been densified. So this is all brand new to me, but that's what I'm doing next. So if you want to see what happens when you make your own sodium silicate and then densify your concrete, you come on back, because that's what I'm doing next. Thanks for watching. Cheers, everyone.